glorious the view was,
sure.
and the pictures from the 1960s and early 70s just could not do justice to that. But now that they're beginning to comment that the high resolution and some of these new images are really beginning to reflect what they actually saw, and maybe the public can start to get more excited just because they can see the grandeur of all this.
Yeah, and as far as the moon goes, my feeling is that private enterprise might step up and be able to do more moon exploration in the future, in the near future, whereas NASA, could, and other national space agencies could focus on some of the more pure science missions that are dedicated to the outer solar system, or to Mars or Venus or wherever. It just seems like, maybe with the Google X Prize, and now with a couple other probes going to the moon, and other people talking about private enterprise going to the moon, I think that would be a good focus for the commercial space business. I don't know, what is your opinion on that, Richard?
Well, there is a newfound focus on Mars, not just private industry, but also NASA and the other space agencies. And there is a new moon race going on right now. Sure. to really detail the moon and plan for the return of humans and to build colonies and such. But in the end of this year, NASA is launching the Lunar Reconnaissance Orbiter, which will return the highest resolution images of Mars. And this is to map in great detail, the moon.
The moon, oh, okay.
Right, and to map in great detail the moon to prepare, for this eventual return by humans. And many other nations kind of are getting into the space race for the first time with missions.
Like China, India, Japan?
China and India. Great Britain has proposed a mission. Sweden is looking at its own mission. The European nation as a whole is coming up with missions.
The European Union, yeah. Interesting, yeah.
It's viewed kind of as a stepping stone into the rest of the solar system, and that's where we should start from. There are other proposals, though. For example, maybe we should use near Earth orbit asteroids as our launching pad instead. Maybe those.
There's even less gravity there for resistance, right? For takeoff.
Right. Right.
Even less, yeah. For near Earth asteroids, I've heard of that for launching pads, but for just resources, raw material. Yes. and whatnot.
Yeah, exactly.
And we have seen in the last couple of years a couple of different systems, or a couple of different probes, satellites that have gone out to asteroids. And I remember the Hayabusa from Japan tried to land on an asteroid and come back. I'm unsure about how that's going right now. They had quite a bit of trouble.
Well, now, now they're just trying to get back. They're limping their way back to the Earth, and it's very uncertain if they'll be able to do so. If they do, it'll be in 2010. But they're also unsure if they actually collected anything from all their mishaps there, if they collected any samples.
Yeah, they had trouble determining whether or not the probe was actually on the asteroid, and then if it picked up any debris, and then if it, I remember seeing, it was quite a hassle.
The next exciting mission to an asteroid is Dawn, Dawn is heading towards Vesta, and one of the dwarf planets, Ceres, which was recently promoted up to dwarf planet.
Dwarf planet status, yeah.
When that was changed. And the interesting thing about Ceres is it's round. It's big enough to be a round body, and from some of the Hubble imagery and other imagery we can get from it, it appears it might have an interesting surface. So we'll see when Dawn gets there.
Sure. We have another question in the chat from John about the imaging systems. What are they? CMOS sensors? What spectrum range do they cover? And how does the false coloring work exactly?
Well, this is going to be a test of whether I'm a high-rise employee or not.
I guess so, yeah. I'll bring up the image, the false color image there of the lander. Just maybe that'll help you explain it a little bit again.
So it's an array of 14 CCDs. There are
14?
10. Yes.
Wow.
So it's like a digital camera, but 14 CCDs. And these are arranged 10 reds down the center, or sorry, from left to right. And then we have two in the center above that are blue-green, and two below that are near infrared. And those overlapping two CCDs, or a total of 6 CCDs down the center, is our center color swath. The rest of our image is in black and white. And our instrument acts as both a telescope and a camera. So it is pointed down to Mars, of course, and the light enters and bounces around and hits the electronics in the back. And that is collected and then sent back to Earth. And that is actually part of my job. I work in what we call downlink. Downlink is the part of our operations that deals with the returned images. So we basically make them pretty and make them available to the public. And most of that's automated now. We use software to process all our data, but we do have to do some hand processing and different things. For the descent image of Phoenix, we actually worked in Photoshop and did a few other little tweaks here and there to try to get it ready for our press releases and that sort of thing. So, and those are minor things. Our images are so huge that if you tried to open them full resolution, they would crash all modern computers. They can be hundreds of gigabytes in size. So So we compress them using a standard called JPEG 2000. And with this standard, if you have